Welcome to EDU World Space.
So, to answer the first part of this question, we know that the particle started at rest and it ended with a final kinetic energy of 1.5 times 10 to the negative 6 joules, or 1.5 microjoules. So, once again, since it started at zero, the total work done must be that 1.5 microjoules. So this question is just making sure that we understand the concepts, and since the particle started at rest, the total work must be equal to the energy that the particle outputted in that distance that it moved. So the first part of the answer is straight from the first answer to the first part of this question is straight off the information that they gave us, just making sure that we understand the concepts. So moving on to part B. So at the same time, we can write the work done by the electric force as a change of potential energy. So we can write that the work done is equal to the charge of the particle times the change in potential energy. So the change of the potential energy times its charge is equal to the work done. So in this case, we're trying to find the change in potential energy. So we need to isolate this part of the equation. So move the charge to the other side. Since we already know W, we know that from the previous part of the question. So if we isolate for the variable U, or V, sorry, in this case, so it's the potential energy. So if we isolate for the variable change in V, we get it's equal to the work done over the charge. So now, if we put this in, we get that the work done is 1.5 and micro is times 10 to the negative 6 over the charge, which we're given is 4.2. Let me just check again to make sure. It's 4.2 nanocoulombs, so it's times 10 to the negative 10, times 10 to the power of negative 9, sorry. So now if you put this into a calculator, if you could just give me a second to put the calculator, over 4.2 times 10 to the negative 9. So if you calculate this, we get that total difference in potential, so the volts is equal to 357.1 volts. Now we're done with this part, since we already calculated the potential energy, which is the potential difference. So now if you move on to part C, so the potential difference is equal to its energy times, so PD, or in this case the voltage, just the change in the voltage, is equal to the energy times the distance, where d is the distance it traveled. So if we isolate for the change in E, we can get, since we already calculated the volts here, remember this is equal to change in V, which is the change in potential difference. Here, let me just make that clear and write this up here too. So potential difference. So the change in E is equal to change in V over D, which we know is 3, which we calculated from the last step. So the potential difference is 357.1 over the distance, which we can get straight off the answer, which is 6 centimeters. So it's 6 times 10 to the negative 2, just putting it in standard units. So if you put this into our calculator, hold on, give me a second, 350 over 6 times 10 to the negative 2 is 5951.7